us about your early life.
Well, I, Erwin Schrodinger, was born to my wonderful father Rudolf Schrodinger as his only child. We spoke English and German because in Vienna, Austria-Hungary, where I was born, that's what we spoke. With me being the only child, I got to appreciate my father's brilliance, which is what led me to be such a brilliant man myself.
Schrodinger worked in the field of quantum mechanics, which is the application of quantum theory to explain the properties of matter, particularly electrons and atoms. Schrodinger decided to approach the problem of atomic structure by focusing on the wave properties of the electron. According to Schrodinger, an electron bound to a nucleus in an atom resembled a standing wave. A standing wave, also called a stationary wave, is a combination of two waves moving in opposite directions, each having the same amplitude and frequency. For example, the waves produced by plucking the string of a guitar are standing waves. Schrodinger discovered that an electron is a circular standing wave around the nucleus. Only certain electron energies are allowed because atoms are quantized. What does it mean when we say that electron energy levels are quantized? This means that the energies of electrons can only have certain specific values. Let's imagine a staircase. The steps are at a specific height. Let's pretend these steps represent different energy levels, with the energy levels increasing in value as you move up from one step to the next. A person is able to stand on a step, but not in between two steps. A comparable situation exists in an atom. There are certain discrete energy levels in an atom, and an electron can only exist at these levels. It cannot exist in between any of the levels. So, an electron can only have a certain amount of energy according to Schrodinger. Schrodinger's equation is the most accurate theory of how subatomic particles behave. It demonstrates all the wave-like properties of matter and defines the probability of finding an atom's electron at a particular point. It also gives information about the shape of atoms. In Schrodinger's atom, the nucleus is surrounded by an electron cloud. Where the cloud is most dense, there is the greatest probability of an electron.
Why, hello, it's me, Erwin. Now, while I was working on that quantum mechanics, I came across a very important equation we call the wave equation. Now, the wave equation really helped us learn a lot of new things about quantum mechanics and the atom. It was really important for helping us discover a number of things. Now, you may be asking, but Schrodinger, what exactly does this wave equation help us find? Well, it doesn't actually help us find anything precisely, but it helps us predict where something might be. Oh, you see, the wave equation helped us find where electrons might be in the atom by showing us the probability of them being at any one point in a given time. So, this was very different from what we had, which tried to predict exactly where an electron was in two-dimensional space, whereas the wave equation is predicting where an electron might be in three-dimensional space. So it's two very different things. And even though it sounds like the first one may have been more accurate, this one is much more accurate because it's not always completely wrong.